What if I told you that our solar system doesn't have just one belt of space rocks, but two completely different regions hiding incredible secrets? One lies between Mars and Jupiter. The other begins beyond Neptune and stretches billions of miles into the darkness of space. At first glance, they may look similar. Both contain countless objects orbiting the Sun. But in reality, they couldn't be more different. One is filled mostly with ancient rocky worlds left over from the birth of our solar system. The other is a frozen kingdom where dwarf planets like Pluto have survived for billions of years. In today's documentary, we'll uncover the truth behind these mysterious regions and discover why they continue to fascinate astronomers around the world. Before we continue, if you enjoy exploring space and want more documentaries like this, make sure to subscribe to the channel and turn on notifications so you never miss our next journey through the universe. Now, let's travel back. About 4.6 billion years ago, our solar system began as a gigantic cloud of gas and dust known as the solar nebula. As gravity pulled this cloud inward, the Sun formed at its center. Around the newborn Sun, billions of tiny particles of rock and dust began sticking together. Over millions of years, these particles grew into larger and larger objects. Eventually, many of them became the planets we know today. But one region of the solar system never finished building a planet. Between the orbits of Mars and Jupiter, something extraordinary happened. Jupiter was growing into a giant. Its enormous gravity constantly disturbed the surrounding material. Instead of allowing small worlds to merge into a planet, Jupiter's powerful pull caused countless collisions, breaking many objects apart before they could fully form. The result was a vast collection of rocky bodies left orbiting the Sun. Today, we know this region as the Asteroid Belt. Located between Mars and Jupiter, the asteroid belt stretches from about 2.2 to 3.2 astronomical units from the Sun. An astronomical unit, or O, is the average distance between Earth and the Sun, about 93 million miles, or 150 million kilometers. Many people imagine the asteroid belt as a crowded field of giant rocks, where spacecraft must constantly dodge dangerous obstacles. But that's actually a myth. In reality, the asteroid belt is mostly empty space. The asteroids are separated by enormous distances. If you were standing on one asteroid, you probably wouldn't even see another with your own eyes. Despite containing millions of objects, the asteroid belt is far emptier than most people imagine. But if this region is made of rocks, then what exactly is waiting beyond Neptune in the mysterious Kuiper Belt? Let's find out in the next chapter. Although the asteroid belt contains millions of objects, only a few are truly enormous. The largest of them all is Eris. Discovered in 1801, Eris was originally believed to be a brand new planet. But as more objects were discovered nearby, astronomers realized it was actually part of the asteroid belt. Today, Eris is officially classified as a dwarf planet. It measures about 940 kilometers, or 584 miles, in diameter, making it by far the largest object in the entire asteroid belt. Scientists have even discovered evidence of water ice beneath its surface, raising the possibility that Eris once had, or may still have, a hidden underground ocean. But Eris isn't alone. Another giant is Vesta, the second largest asteroid in the belt. Unlike Eris, Vesta isn't round enough to qualify as a dwarf planet. Its surface is covered with enormous impact craters created by violent collisions over billions of years. One of those impacts was so powerful that pieces of Vesta were blasted into space. Some of those fragments eventually traveled across the solar system, and even landed here on Earth as meteorites. Then comes Pallas, another massive asteroid with a strange orbit. Unlike most asteroids that travel in nearly the same flat plane as the planets, Pallas follows a highly tilted path around the Sun. Scientists believe its unusual orbit may have been caused by ancient gravitational interactions during the early history of our solar system. The fourth giant is Haumea. Although smaller than Eris, Haumea is nearly spherical. Some astronomers believe it may also qualify as a dwarf planet in the future as more observations become available. Together, these four objects contain nearly half of all the mass in the entire asteroid belt. But here's something surprising. Even if you combined every single asteroid in the belt into one giant object, its total mass would still be only about 3% of the Moon's mass. That's incredibly small. which explains why the asteroid belt never had enough material to form a full-sized planet. And while these rocky survivors remain trapped between Mars and Jupiter, far beyond Neptune, an even larger and colder region was slowly taking shape, a place filled with frozen worlds, ancient dwarf planets, and billions of icy objects that have barely changed since the birth of our solar system. Welcome to the mysterious Kuiper Belt. Next chapter. Beyond Neptune, entering the Kuiper Belt. As we leave the asteroid belt behind, our journey takes us farther from the Sun than most people can imagine. We pass the orbit of Jupiter, then Saturn, then Uranus, and finally, Neptune. Beyond Neptune lies a mysterious region that remained completely unknown until the late 20th century. For decades, astronomers believed the solar system simply ended there. But they were wrong. In 1992, scientists discovered a small icy object beyond Neptune. That discovery completely changed our understanding of the solar system. It proved that Neptune wasn't the end. It was only the beginning. This enormous region became known as the Kuiper Belt, named after astronomer Gerard Kuiper, who predicted that icy bodies might exist beyond Neptune. Unlike the asteroid belt, which is made mostly of rock and metal, the Kuiper Belt is dominated by ice. Not just frozen water, but also frozen methane, ammonia, nitrogen, and carbon monoxide. Temperatures here can drop below -220 degrees Celsius, or -364 degrees Fahrenheit. Sunlight is so weak that the Sun appears only as an extremely bright star in the sky. The Kuiper Belt begins at about 30 astronomical units from the Sun, just beyond Neptune's orbit. It stretches to nearly 50 astronomical units. To put that into perspective, Earth is only 1 astronomical unit away from the Sun. That means the Kuiper Belt begins almost 30 times farther away than our own planet. And unlike the asteroid belt, the Kuiper Belt is far larger. It is about 20 times wider and contains hundreds of times more material than the asteroid belt. Scientists estimate that it contains millions of icy objects, with thousands large enough to be classified as dwarf planets. The most famous of them all is Pluto. For more than 70 years, Pluto was considered the 9th planet. But in 2006, astronomers officially reclassified Pluto as a dwarf planet because it shares its neighborhood with many other icy worlds inside the Kuiper Belt. That single decision sparked one of the biggest debates in modern astronomy. Was Pluto really no longer a planet? Or had we simply discovered a much bigger family of worlds beyond Neptune? And Pluto is only the beginning. The Kuiper Belt hides many more incredible objects, some even stranger than Pluto itself. In the next chapter, we'll explore the giant frozen worlds that call the Kuiper Belt home. Pluto may be the most famous object in the Kuiper Belt, but it is far from the only remarkable world hidden in this frozen frontier. In fact, astronomers have discovered several dwarf planets that are just as fascinating as Pluto. One of them is Haumea. Unlike most planets and moons, Haumea doesn't have a round shape. It spins so incredibly fast that one complete rotation takes less than 4 hours. That rapid spin has stretched it into an oval, almost football-like shape. Haumea is also surrounded by a thin ring and has 2 small moons orbiting around it, making it one of the most unusual objects in the solar system. Next comes Makemake. Discovered in 2005, Makemake is slightly smaller than Pluto but is covered with frozen methane and other icy materials. Its bright surface reflects sunlight, making it one of the most reflective objects in the Kuiper Belt. Then there's Quaoar. Although less famous, Quaoar surprised astronomers when they discovered it also has a ring. According to earlier theories, a ring shouldn't be stable at that distance from the object. Yet Quaoar proved that nature can still surprise us. And then there's Eris. When Eris was discovered in 2005, astronomers realized it was nearly the same size as Pluto. Some measurements even suggested it might be slightly more massive. That single discovery forced scientists to ask a difficult question. If Pluto is a planet, should Eris also become a planet? And if the answer is yes, how many more planets would we eventually have to add? To solve the growing confusion, the International Astronomical Union created a new category in 2006. Dwarf planets. As a result, Pluto and Eris were both placed into this new classification. Today, astronomers consider Eris to be part of the scattered disk, a distant region beyond the main Kuiper Belt, although it is often discussed alongside Kuiper Belt objects because of its discovery and importance. These frozen worlds completely changed our understanding of the outer solar system. They proved that beyond Neptune lies not an empty void, but an enormous population of ancient icy worlds that have remained almost unchanged for billions of years. And these objects don't just sit quietly in space. Some of them eventually begin an incredible journey toward the inner solar system, transforming into one of the most beautiful sights in the night sky. Comets. Next chapter. How the Kuiper Belt creates comets. The Kuiper Belt doesn't just contain frozen worlds. It is also the birthplace of many of the comets that light up our night sky. For billions of years, countless icy objects have quietly orbited the Sun in the freezing darkness beyond Neptune. Most of them remain there forever. But every now and then, everything changes. The gravity of Neptune, or a close encounter with another Kuiper Belt object, can slightly alter an object's orbit. That tiny change is enough to send it on an incredible journey toward the inner solar system. As the object moves closer to the Sun, temperatures begin to rise. The frozen ice on its surface slowly turns directly into gas. This process is called sublimation. The escaping gas carries dust and tiny particles into space, creating a glowing cloud around the comet known as the coma. Then something even more spectacular happens. The pressure of sunlight and the constant flow of charged particles from the Sun, known as the solar wind, push this material away from the comet. A magnificent tail begins to form. In fact, most comets have two different tails. The dust tail, which appears white or golden, and the ion tail, which glows with a bluish color. One fascinating fact surprises almost everyone. A comet's tail never points behind the comet because of its motion. Instead, it always points away from the Sun, no matter which direction the comet is traveling. Some of these icy visitors become famous throughout history. One of the best-known examples is Halley's Comet, which returns to the inner solar system about every 76 years. Although Halley's Comet actually comes from a different region called the Oort cloud, many short-period comets, those that return in less than 200 years, originate in the Kuiper Belt. Without the Kuiper Belt, many of the spectacular comets seen from Earth would never exist. It is far more than a distant collection of frozen rocks. It is an active region that continues to shape our solar system even today. But now comes the ultimate question. If both the Asteroid Belt and the Kuiper Belt orbit the Sun, which one is actually bigger, colder, and more mysterious? Let's compare them side by side in the next chapter. Now it's time for the ultimate comparison. The Asteroid Belt versus the Kuiper Belt. At first glance, both may seem like giant rings of objects orbiting the Sun. But in reality, they are completely different worlds. Let's begin with location. The asteroid belt lies between Mars and Jupiter, only about 2.2 to 3.2 astronomical units from the Sun. The Kuiper Belt begins far beyond Neptune, stretching from about 30 to 50 astronomical units away. That means the Kuiper Belt starts nearly 10 times farther from the Sun than the asteroid belt. Next, let's compare temperature. Inside the asteroid belt, sunlight is still relatively strong. Temperatures can vary from around -100 degrees Celsius to over -20 degrees Celsius, depending on the object's location and surface. But the Kuiper Belt is a completely different story. Here, temperatures can fall below -220 degrees Celsius. At these extreme temperatures, water, methane, nitrogen, and even carbon monoxide remain frozen solid. Now let's look at composition. Most asteroids are made of rock and metal. Many contain iron, nickel, and silicate minerals. They are the leftover building blocks of the inner planets. Kuiper Belt objects are mostly made of ice mixed with rock. Their surfaces contain frozen methane, frozen nitrogen, and frozen water that have survived for billions of years. What about size? The asteroid belt contains millions of objects. But the Kuiper Belt contains far more. Scientists estimate that it holds hundreds of thousands of large icy bodies and millions of smaller objects. In terms of overall size, the Kuiper Belt is about 20 times wider and contains hundreds of times more material than the asteroid belt. And finally, which one is more important? The asteroid belt helps scientists understand how the rocky planets formed. The Kuiper Belt helps us understand how the outer solar system evolved and where many short-period comets come from. Both regions are like giant time capsules. They preserve material that has remained almost unchanged since the birth of our solar system over 4.6 billion years ago. But our journey doesn't end here. Because beyond the Kuiper Belt lies an even more mysterious region, a place so distant that it may mark the true edge of our solar system. Welcome to the Oort cloud. Next chapter. Beyond the Kuiper Belt, the final frontier. After traveling billions of miles across our solar system, from the rocky asteroid belt to the frozen worlds of the Kuiper Belt, one thing becomes clear: our solar system is far more complex than we once imagined. The asteroid belt is a collection of ancient rocky fragments, the leftover building blocks of planets that never had the chance to form. The Kuiper Belt is an enormous frozen frontier, home to dwarf planets, icy worlds, and the birthplace of countless short-period comets. Together, these two regions preserve a history that is over 4.6 billion years old. Every asteroid, every frozen object, every distant world, is a surviving piece of the incredible story of how our solar system came to exist. Even today, scientists continue discovering new objects beyond Neptune. Each discovery reveals another piece of a puzzle that is still far from complete. And perhaps the most exciting fact of all, we've explored only a tiny fraction of our own cosmic neighborhood. There are still millions of worlds waiting to be discovered. Future missions may uncover hidden oceans, completely new dwarf planets, or even rewrite everything we think we know about the outer solar system. The greatest discoveries may still be ahead of us. Because in space, every answer creates an even bigger question. And that's exactly what makes the universe so fascinating. If you enjoyed this journey through our solar system, don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next space documentary. And tell us in the comments, which region fascinates you more? The rocky asteroid belt, or the mysterious Kuiper Belt? Thank you for watching. Until next time, keep looking up, because the universe is far bigger than we can ever imagine.